Um, First of all, I would like to ask whether you have any questions regarding what we did last week. Anything you need to know, anything you need to clarify? Okay, so we last week we talked about data. Finally, we talked about data. What when we are doing when we are collecting data. After collecting data, what should we do? First of all, what kind of data we have collected? What other things that can be there with the real data, with the correct data? Okay, those kind of things we talked about in the last week. So mainly about data quality and how we can increase the data quality, those kind of things. So we will talk about data collection. So I would like to just ask any from any of you, what kind of what are the data collection methods that you are familiar with? What are the data collection methods? Can anyone, Venuri, can you tell me what are the data collection methods that you know or you are familiar with? Yes, Venuri, are you there? Venuri? Anybody else, can you tell me what are the data collection methods that you know? I mean, how are you going to collect data? If somebody asks you to collect some kind of data, which methods you can use to collect those data?
Conducting meeting.
Meetings, okay.
Questionnaires.
Questionnaires, yeah. By meetings, you mean interviews, right?
Yes.
Yeah, we can interview a person and we can collect data by the responses that that person is giving. Any other methods? Anybody else?
Preparing existing documents.
Yeah, you can use existing documents and get data from it. Yes. Any other methods?
Conducting meetings.
Yeah, you mentioned that. Okay, so yeah, good. Thank you, Chamesh, right? Those were some data collection methods. You can interview a person, and by the answers that person is giving, you can collect certain data. You can give a questionnaire to a person or a set of people, and you can collect the data based on the answers that they are giving to the questions. You can observe a person while a person is working. For example, let's say you have developed a software application, a new software application you have developed. So afterwards, you want to know uh, before the final output, you want to know whether this software is ideal for the people, whether the people will like it, whether the people will be able to easily understand it, things like that. So what you do is you get a collection of people, maybe random people or maybe people that you know, and then you give that software to that people and ask them to work on with it. Then you observe whether that person is easily understanding that application, whether that person is struggling, whether the application is complicated to the person, things like that. How much time the person takes to correctly understand the application, those kind of things you can observe. So by observation also you can collect data, right? And by reviews from the people. So in the similar situation, you can give a software application to a set of people to work with it and then you can get their reviews, whether it is complex for understanding, whether they can easily understand it, whether it is user friendly, those kind of things. You can get the reviews from the people who are using that application. So before deploying the application, you give that application for a set of people and see. So normally Microsoft applications like Microsoft operating systems, when a new operating system is being launched, let's say before Windows 10 or Windows let's say Windows 16 is coming, right? So before putting this Windows 16 into the market, what the Microsoft people are doing is they are giving a free period of time where people can download Windows 16 and use it in their computer. And then they will ask for reviews, whether that application, whether that operating system is good or bad, or what was it, what they have expected, those kind of things. The Microsoft people will ask from the people who have tested the trial, right? So by like that. So there are a lot of kinds of data collection methods. So data collection methods can be divided into two sections or two types. One is primary data collection method, the other one is secondary data collection method. So primary data collection method means you directly get the data that you want, you directly get the answers, right? So statistical methods, you can get a set of data and you can do some analysis with the data and you can get some answers, right? So here the data will be recorded. You are recording data. You are recording the data, maybe you are measuring the data, you are physically measuring the data. Mostly scientific data will be recorded with this method, statistical methods. And you can provide surveys. Surveys means something like questionnaires. So you can give a set of questions to a set of people and then you can ask them to answer it. So based on the answers, you can directly get the data from the people. You can create polls. That is what happens in the presidential and all the elections in our country and in the most of the countries in the world. So you vote, you give your vote based on the categories who are asking for the votes. So those are polls. So there also we can directly get the data, which candidate is mostly preferred by the people, things like that, right? Interviews also, you are directly asking the questions and then the person is directly answering it. So at that moment itself you are collecting data. Okay, and What do you mean by Delphi technique? Does anybody know what a Delphi technique or Delphi method is? So in a Delphi technique, what happens is you have a group, right? You have maybe a group of experts, and then you do a survey. You provide a survey, or you give a set of questionnaires, and the responses will be taken from that group, and then you give maybe other questionnaires, or maybe other maybe the same responses, and then you take the same responses and give to that group again, and based on that responses the group will again discuss and give some opinion, right? So that is what usually happens when some incident happens in a country. I think there are a lot of examples in Sri Lanka. Whenever some incident happens, a panel of experts will be allocated to study that incident, right? And then they should give their opinion. So maybe based on that opinion and other data which is around them, all that data will be given to them again, and based on that data again they will survey or do something and give their opinion again. So the same data will be aggregated, right? The same data will be aggregated and shared with the same group again and again. Maybe the same group, maybe different groups. So that is what happens in our country. Normally, when some incident happens, a group of experts, as they say, they are saying that they are a group of experts, but usually what happens is they are biased into a certain politician, and the results will come with the favor of the politician, not with the favor of the normal people in the country. So that is a corrupted method in our country. What is happening? Okay. So normally Delphi technique works like that, right? So there are a group of experts about a certain field, and the data will be provided to those experts. So they will do some analysis and discussions and things, and then they will give an output. So sometimes this output will be taken, maybe moved into another field or moved into another body, and or maybe that same data with same data and some other data will be given again to those experts to do an analysis again. So it is somewhat an aggregating method. Right? Focus groups also, it is somewhat similar like that. So there are also a set of experts related to a certain field will be there, and data will be given to them to do analysis and give an output. So they are only focusing on a particular field that they are familiar with. So like that, there are those are primary data collection methods. So you can see here, primary data collection means the data can be taken or the data can be obtained from whatever source directly. We do not have, we don't need to analyze, or we don't need to select or categorize or do anything for these kind of data. But secondary data collection methods, as you can see here, they are mostly based on reports. So financial reports, sales reports, government reports, mission, vision statements, the internet. So here we cannot directly obtain any data, right? So when we take a financial report, we have to read the financial report, and we have to maybe categorize the data there. We have to we can, I mean, we have to abstract only the data that we need in these financial reports or any report, right? So unlike in an interview or survey or any statistical method, we cannot directly obtain the data, but we have to maybe categorize, maybe get an abstract. We have to do something like that in order to obtain secondary data when we are working with secondary data, right? So those are the two differentiations that when we are doing data collection, there are primary data collection methods and secondary data collection methods. So why do we need to collect data? Why do we need to collect data? We can just based on one or two information or data that we have, we can give an opinion. But why do we collect a large set of data and maybe do an analysis and do lots of things in order to make a decision? Why do we do it? So if we have a large set of data, that large set of data will help you to learn more about the situation or about anything. So for example, if you are doing a business, it is better if you can learn more about your customers, right? If you can if you know what the customers like, what the customers prefer, if you know those kind of things, you will be able to give a better service to your customers. So how are you going to know about your customers? It is based on the data that they give, based on the data that is recorded related to the customers, right? So it enables you to discover trends in the way people change their opinions and behavior over time or in different circumstances. So people are not the same every day. I think you can experience that situation nowadays. People are not the same. So they change their opinions. They change their behavior, right? Over the time or according to different situations. So based on the data, you will be able to learn how much people have changed, what are the people's opinion now, those kind of things. So for that also you can get so many examples with the current situation in the country. So people have 2 years back, people have respected and invited a person as the president, but now the people are chasing him away. So that is how the opinion and the behavior of the people, how they have changed it, right? So another point why you are collecting data, it lets you segment your audience into different customer groups and direct different marketing strategies at each of the groups based on their individual needs. So not all the customers are similar. So if you are running a business, there are different kinds of customers based on various characteristics. So some customers will be there, they will buy the most expensive food that you have. Some customers will be there, they will be with you for a long time, right? So like every time they used to buy a certain product only from you, those kind of VPN customers or gold categorized customers like that. special customers will be there, and maybe according to the age of the customer, those kind of things, the customers differ, and according to the desires of the customers, what the customer likes, according to lot of lot of ways or lot of reasons, the customer, there can be different customers. So you can segment your customer or customers, segment your audience. So you can build categories. So these are the gold customers, these are silver customers, platinum customers, right? Bronze, like that. So based on the amount of time that they are associated with you, based on the sales or buyings that they are doing from you, based on those kind of things, you can categorize them, right? So in order to categorize them, you have to have data related to those customers. Data also facilitates decision making and improves the quality of the decision which is made. So not just by making a decision without a proper collection of data, sometimes it won't be the best decision that you are making. So if you have more data and more information about maybe certain set of customers like that, you can make a better decision, a quality decision, right? It helps resolve issues and improve the quality of your product or service based on the feedback obtained. So it is somewhat similar thing like the one I have mentioned before. So you can improve the quality of your products based on the feedback or the reviews that the customers are giving. So for example, you are running a food shop. So the customers will eat whatever you are selling, and then they will give you a feedback. They will put a feedback online. They will say that the food is good and things like that if they are satisfied. But if they are not satisfied, they will blame you, or they will give a bad review. So you can look at them and identify what is the problem with your food. Maybe your food is I don't know, too dry or something like that. So you can improve it. Or maybe the quality, the service quality is not good. Things like that the customers can review. So you can improve them based on the reviews that they are giving. So because of the large set of data that you can collect, you can get these advantages, right? You can get these advantages. So data can be divided into two parts, or into two kinds of data. So they can be quantitative data and qualitative data. All the data that we are collecting may be based on surveys, maybe direct collections, measurements, or anything. We can put the data that we are collecting into two categories. Into one of these categories, the data can either be quantitative or qualitative, right? So quantitative data means it deals with the things that are measurable. So quantitative means quantity. We can give a we can we can measure the data in a quantity, right? And it can be expressed in numbers, or maybe figures, or any values that can express quantity, right? So for example, size, length, duration, amount, price, those kind of data. So size, we can say it is small, or you can give a measurement like 2 meters, 3 meters, things like that. And duration, what is the time range, 1 hour, 2 hour, things like that. Amount, how much, how many, 1, 2, 3, like that. And the price, 100, 200, like that. So we can express the figures, we can express them in numbers, right? We can talk about these data in numbers. So normally quantitative data can be obtained by questions like who, when, where, what, and how many. So when we ask who, there is a certain name or certain person's name or certain institute or whatever name associated with it. So how many times that name is associated, we can obtain the data. We can obtain the number of times that name is associated with the question who, when, what is the time, where, maybe the location, maybe latitude and longitude values of a certain location. So for these kind of answers, we can obtain quantitative data. The next kind of data is qualitative data. So here, rather than expressing the data in a numerical value, we are expressing it in a descriptive value. We are describing the data. So rather than mentioning the size as 1, 2, or 1 meter, 2 meter, things like that, we can express the size as small, medium, large, like that. So it is a quality. We are talking about the quality of the data. So the quality of the data, it is normally not easily measurable. So as in quantitative, we can just take the set of data and we can measure it. Right? We can measure right? We can measure a set of data in a quantitative way by using numbers in quantitative data. But in qualitative data, we do not have numbers to measure something, right? So it is not easily measured as in quantitative type. Okay. Qualitative data can be gained through observation or open-ended survey or interview questions. So we can obtain qualitative data through observation. So as I mentioned before in a previous example, we can get reviews from people, or we can observe people working, and we can get an idea whether that person is confident with using the particular product or things like that. Or we can use open-ended surveys where people will give their ideas. We are not giving questions one by one in this survey. We are not giving a questionnaire. So people will express their thoughts, or people will describe what their opinions. So the opinions will be different from one person to another, right? So when we collect this kind of data, we have to go through that data again in order to maybe categorize the data into different sections, things like that. So it is not easy, and it is not directly measurable as quantitative data. So normally qualitative data provide answers to questions such as why and how. So normally thoughts, feelings, those kind of data can be categorized as qualitative data, right? So thoughts of people, not all the people's thoughts are the same, right? So if you take the current situation, there are some people who are directly mad with the government, and there are some people who are neutral, they are not expressing their ideas. There are some people who loves the government, so that is due to different, that can be due to different reasons. So things like that, right? Feelings and thoughts will be can be measured and obtained qualitative data, right? So you can see here closed-ended surveys means usually online quizzes are closed-ended surveys. So you have a set of answers. You can give only from these answers, right? So for example, which one of the Christmas specials do you like the most? Santa's coffee, Rudolph's chocolate, or something. There are there are four options here. You have to choose one from these four options. You cannot express your ideas otherwise. So that is closed-ended surveys. In open-ended surveys, however, in open-ended surveys and questionnaires, they do not provide a set of answers to select. You have to give your opinion, or you have to write, or you have to express your thoughts, right? So that is open-ended surveys. One-on-one interviews means the general interviews that you can see. So one person is asking questions, the other person is answering them. So there you can get quantitative data, right? Focus groups, here also a group which is which has a set of experts in that group. They will give their ideas regarding to some question, and that data will be collected. So they are also, since the people in that group are focused on only one field, they will not there will not be a very large amount of different kinds of data. So the data will be focused on a particular field or a particular situation, like that. Direct observation also, we can observe a person and we can determine whether that person is doing good with the product or doing bad with the product. Good and bad. So we can maybe we can measure the time that the person is taking to understand something. For example, like the example that I have mentioned before, we can give a new application that we have developed, a software that we have developed, we can give to a person or a set of persons to work with it, and we can measure the time they are using to do some task. Let's say I'm giving the application and I'm asking them to do something from it. So how much time they are taking to do that particular thing, we can directly observe. So that time will be a quantitative data. Okay. So this is an example for a closed-ended question. So you are asking a question and you are giving a set of answers. So the person who is answering it can choose either one or several answers. So in open-ended question, you are asking the same question, but you are not giving a set of answers. So that person can describe describe or explain his answer to the question that you are giving. So that is so open-ended questions normally can be qualitative data. Or closed-ended questions normally are quantitative data, right? Okay, any questions regarding these types of data? Do you have any questions regarding data types?
No, ma'am.
Okay, so we can talk about data preparation then. So after we collect the data, we have to prepare the data. We cannot use that data that we have collected directly in the analysis, right? So we have to prepare the data. So data preparation is actually the process of cleaning and transforming raw data before analyzing, right? So we have to clean the data. We have to transform raw data into some other kind of data before processing or before analyzing the data. It is actually an important step. So usually what we do is we reformat the data, we correct the data, we sometimes combine the data sets and we enrich the data, right? So why are we doing this kind of data preparation? After preparing the data, we can efficiently analyze this data. We can limit errors and inaccuracies that can occur to data during processing. So if we have erroneous data with the data set, or if we have the same data again and again, maybe duplicated data, or if we have a data which is in the wrong format, it will take time and it will make more errors when we are using that data in our analysis, right? During the analysis process, if we have those kind of mistakes in the data that we have collected, the output will be erroneous. It makes all processed data more accessible to users. So users can access the data. It is more accessible to users because all the data will be in a certain format. All the data will be corrected. There will not be erroneous data. And if there are duplicated data, we can combine the data sets and we can enrich the data. So those are the reasons why we are doing data preparation. So the main reason is to enrich the data and get a correct analysis. Okay, so this is normally what happens in data preparation. So we gather the data, we discover things like we discover whether there are duplicate data, we discover whether there are noise in the data, okay, things like that, errors in the data, those kind of things we discover, and then we cleanse the data, we remove any noise. If there are any noise, we remove them. If there are erroneous data, we maybe remove them. If there are missing values, we can either remove the objects or maybe we can insert another value into that missing place. Like that, we do some things, we cleanse it, we cleanse the data. So after we cleansing the data, clean data are there with us, right? After we cleanse the data, we have a set of clean data, a data set without errors. And then we take that data and transform. So maybe data formats may be different, right? So we can transform the data from one type to another, right? And then after transforming the data will be automatically enriched, right? The data can be enriched. So there is a set of rich data with us after cleansing and transforming a set of data. Then we store this data in somewhere. So afterwards we can get this data for processing. So this is the way how we are preparing data. Before analyzing the data, we have to prepare the data. Okay, so you can see here data preparation. These are the things that you can do in order to prepare the data. So I need you to go through this slide and read and let me know if you have any questions regarding this data preparation thing, right? So we gather the data, we discover the what are there in the data, we cleanse it, we transform the data, and we store the data. So you can read what kind of things we can do in these steps. Okay, I will give you a little bit of time to go through this slide, and if any one of you have questions regarding it, you can ask. Okay, So any questions related to this section, data preparation? I think you can understand this, right? So what are the things you can do? What are the things you are to do in data preparation? Okay. So yeah, this is a kind of example here. When you are preparing data, so for example, in there's a state named California in the US. So that state's name can be represented using these letters. You can use either CA or Cal, Cal and a dot, or a Cal without dot, like that. So all these three resembles the word California. So in a data preparation phase, what you are doing, what you can do is you can replace all these three names into one name, maybe California or maybe CA or something like that. So that is the kind of thing that you are doing in data preparation, right? So okay, so I'll so there's a link here where you can see some examples of data preparation. So I will send you this lecture note. You can go through it and you can use this link to just view the example, right? So next we will talk about data mining. So the real world applications of data mining and types of inference and statistical hypothesis testing, those kind of things. So I think I have explained this thing here, this circle here, about data mining. So what we are generally doing is we have a business goal. So we first of all identify the data that we have, we prepare that data, we evaluate or we model that data, and then we present the results. And based on that results, we are making decisions in order to go to our business goal. So that is the thing which is happening again and again. So data mining can be used to do all of these things, right? So yeah, so in data mining we can we have certain techniques or certain strategies where we can mine or we can process our data. So there are a set of strategies here. So I need you all to go through these strategies and read these things. Okay, read the things in this slide, and if you want to like further read about it, you can use the internet and read about them. So I'll give you a little bit of time. So afterwards I will be asking you to explain any of these strategies, right? You need to explain. So all of you have to do this. I'll ask you to explain any of these strategies, not a very large explanation, just the idea. So I'll give you a little bit of time. What you have to do is you have to go through these data mining strategies or data mining techniques, right? Classification, prediction, association rules, what is happening there. You have to explain it. You can read the things in this slide and you can use the internet to get more information. Okay, so I'll give you a little bit of time, like around 15 minutes, right? And then I'm going to ask you to explain each and every each of these data mining techniques. Okay. So you need to explain. Yes, did you go through them? Did you go through the techniques? Can somebody explain what is meant by classification? What do we normally do in classification? Can somebody volunteer and explain? I need your idea. It can be right or wrong, it doesn't matter. What you have understood, you have to talk.
Classification is used to classify the data in various categories, to divide the data in various categories.
Yeah, exactly. So in classification, we divide the data into various categories. So it is like categorizing the data. It is the very basic form of analysis. So let's say we have a set of I don't know, books. Maybe we have a set of books, so we can divide this set of books into novels, into science fiction, biographies, maybe exercise books, things like that. So we have the categories with us, we know the categories, and we divide these books into the existing categories that we have, right? So in the bookshelf also we can store the books according to the different categories. For each shelf we can keep the books with the specific categories, like that. So that is classification. Okay, so in maybe in a business or in an enterprise, we can classify whether that was a purchase or a non-purchase, things like that. Okay, and can anybody else explain about prediction? Any volunteer can you explain about prediction? Yes, come on, hurry up. Anybody? So I'm going to ask all of you, so you better volunteer by yourself. Yes, Vinicia?
It can help to business leaders make better decisions and add value to the effort of the analytic teams.
Yeah, prediction is actually we are trying to make a decision, a future decision, right? We are trying to make a future decision, or we are trying to identify something which will happen in the future. So it is somewhat similar to classification, but here what we are doing is we are trying to predict a numerical value, a numerical variable. So for example, if you are working in a shop, or if you are a shop owner, so you will at the end of each month you will check how much sales you have done in this month, and how much sales you will need to do in the next month, and how much raw materials you can by that you can determine how much raw materials you have to buy in order to make the products for the next month. So prediction means based on the current data, or based on the past data, you are deciding something for the future, right? So so certain things or certain decisions are made based on predictions. So for example, climatical changes. In climatical changes, what happened? So constant observations are being done according to about the things which are happening in our climate, in our surroundings. So based on maybe the temperature of the environment, based on the humidity, the pressure, those kind of things, scientists can predict there will be a storm coming, there will be what do you say, there will be no rain coming. So things like that they can predict. So based on the past and current data, they are predicting, they are deciding for something in the future. Okay, and association rules. Who can say about association rules? Yeah. Can somebody voluntarily say, explain about association rules? Anybody?
It is a frequent patterns, correlations, and associations or causal structure from data sets.
Yeah. So correlations of
Yeah.
data sets. So one set of data you have. So what goes with that set of data? That is the thing that you are determining in association rules. So you have maybe, for example, with the increase of temperature, people are buying certain drinks, right? So with the increase of temperature, people are buying certain drinks. So when the temperature is increasing day by day, and maybe when the temperature is greater than a certain cutoff value, then people tend to drink more, maybe water, maybe other soft drinks, things like that, right? So based on the temperature, or temperature in the surroundings or the climate, then more and more drinks and similar products can be sold. So if you can identify that association between the temperature and certain products, then you can increase the sales, and people will buy them more than in the past. And what else? So that is those kind of examples can be talked with association rules. So correlation means how much related are two variables, right? For example, temperature and certain drinks. How much are they related with each other? So that is called correlation. Okay. So okay. So can somebody else describe predictive analysis or predictive analytics? Did anyone search about predictive analytics?
Use algorithms to discover the knowledge and find the best solutions.
Yeah, actually. So here predictive analytics means it is actually a combination of classification and prediction and certain kinds of analysis. So we are using all of these things, all of these strategies, all of these techniques. We are using classification techniques, we are using prediction techniques, and we are doing some analysis using them. So what we actually do is we can use historical data, and we can use certain algorithms like machine learning and artificial algorithms which can be used in artificial intelligence. Okay, and we can predict what will happen in the future, right? We can predict what will happen in the future. So this is predictive analytics is a little bit more complex than just predicting something. Prediction, rather than prediction, predictive analysis, here an analytics part is there. So we can use classification and any tools and techniques related to machine learning and artificial intelligence in this predictive analytics. Okay. Okay, can anybody explain about clustering? Yes, what is clustering? What is clustering?
It is a division of the data into group of similar object.
Yeah, can you explain the difference between clustering and classification? So classification also we are dividing data into specific groups.
Clustering can be viewed as a data modeling technique, and
yeah, both of them can be used as data modeling techniques. So thank you. The main difference is in classification, we know the categories that we are going to classify. For example, as I mentioned previously, we know that the books can be either novels or science fiction books or biographies or things like that, books like that. But in clustering, we do not know the categories. We do not know the categories yet. Based on the data itself, based on the characteristics of the data, we are categorizing data with similar characteristics together, right? For example, we have, let's say we have a set of balls in a container. We have a set of balls. We don't know what are the colors of the balls. I mean, previously, prior to categorizing, we do not know the colors. There can be red, green, blue, and any other colors. So we have a set of buckets with us. We are going to put the red color, we are going to take one ball and examine the color. So that ball is red in color. So we put the ball into one bucket. Then we take the next ball and we examine the color. So let's say it will be green. So we put it into another bucket. Then we take the third ball, and when we are examining the color is red, but it is not as red as the ball that we picked up on the first place. However, it is red. So the color is quite similar to the first ball. So what we are doing is we are putting that third ball into the same bucket that we put the first ball into, because the colors are somewhat similar. So one can be dark red, one can be light red. However, since the colors are similar, the characteristic color is similar. So we categorize them in those. We categorize those two balls together, right? So like that. So with the objects with similar characteristics, we are going to categorize with each other. We are going to build one category for that. Okay, so previous to categorizing this, we do not know how many categories we will get. We do not know what are the categories that we will get. So that is clustering. We are building clusters, and inside the cluster there are objects with similar characteristics. But in classification, we already know what are the categories that we are going to divide the objects into, right? So when we go to throw a trash, we can see one bucket accepts plastic only, one bucket accepts non-plastic ones. So there are two categories, right? So So that is classification. Based on the characteristics, we are putting our trash into one bin. So we have only 2 bins there. But in clustering, we do not know, there can be 2 or several categories. So that is based on the characteristics of the objects. Okay, did you understand? Any questions regarding that clustering and classification?
Can you explain again, ma'am?
Okay. Okay, I'll show you. Okay, so if you can see this image here. Okay, I'll just show this. So okay, so you can, I think you can see this image. So in this image, you can see there are several animals, right? So there are rabbits, ducks, goats and cows and something. So there are farm animals, right? There are several farm animals. So if we take classification, if we take a classification method, you can see in this GIF here. So initially there are set of animals, farm animals, and if we take classification, we can classify into different categories. All the animals can be classified into different categories. So one category can be ducks, goats, hens, then who are sheep, rabbit, like that. So you can see there are different categories that we already know, right? But if we take clustering, let's say we do not know the names of these animals. We do not know the names of these animals. So when we take clustering, when we divide these categories as clustering, we can get only 2 categories. One is the ducks and the hens are there, the turkeys and those bird like animals are there in one category, and the other set of animals like mammals, right? The mammals are there in the other category, right? So that is how that division is done based on the characteristics of these animals, right? Based on the characteristics of these animals, we are dividing it into 2 categories. That is clustering. So the characteristics means they have feathers. So some animals have feathers, they have 2 feet, they are non-mammals. So animals which have similar characteristics will be put into one category, and the other animals with other similar characteristics will be put into another category. So that is clustering. But if we are doing classification, we have a much broader set of categories where we can divide the animals, because we know the categories that we are going to divide in classification. So did you get the point?
Yes, ma'am. It's okay.
So so you can see in this kind of image, so the objects with similar characteristics are grouped together. So we do not know these three groups. These three groups we don't know, but we know that these objects here have similar characteristics. These objects here have similar characteristics with each other, and these objects here have similar characteristics with each other. So we are grouping each set of objects with similar characteristics, and then afterwards, after grouping only, we know that we have three categories of objects here. Before grouping, we don't know that there will be three categories of objects. So that is clustering, right? But in classification, we already know the categories, and we are putting or classifying these objects based on the categories that we know, right? So classification, number of categories is known. Clustering, number of groups is unknown. Okay, so that is the difference between clustering and classification. Okay, so anybody else, can you explain data reduction? Can anybody explain data reduction?
It is a process that reduces the volume of original data and represents it in a much smaller value.
Yes, exactly. So if we have a very large amount of data, we can reduce that data into a small amount of data for the easiness of our classification. So only the sensible data, only the required data is extracted from that large amount of data. So the large amount of data can be complex, right? So we can divide that data, or we can break that data into simple data, right? So sensible data analysis can be done using this data reduction. So as in the name itself, we are reducing the amount of data. So maybe things like unwanted data or unrelated data can be there. So we can either remove them, or we can reduce the complexity of the data by using data reduction. Okay, so data visualization means exploring data to see what information they hold through the graphical analysis. So we can just by looking at the set of data, just by looking at the text format of the data, we cannot identify any patterns, or we cannot see things clearly in order to make a decision. So we normally, what we do is we visualize the data. We either put that data into a chart, or into a bar graph, into a line, or anything, right, into a map, and then we can visually see the set of data. So data with similar characteristics will be grouped with each other, and we can make decisions easily based on the visual data, right? So rather than just reading a set of data, we are able to identify patterns, and we are able to understand the data more clearly by visualizing the data. Okay, so these are the techniques and strategies that we can do regarding data with data mining. Okay, so what happens in data mining is we have historical data. We build predictive algorithms based on the historical data, and we use predictive algorithms. So these algorithms are already there. So the scientists and the mathematicians have built these algorithms. So we use historical data, and we use predictive algorithms in order to create a model, right? So we create a model, and this model is there. Model is static. This model will not change. Then what we are doing is we take new data or the current data. So this is historical data. This is current data or new data, and we put that data into that model, the model that we have built based on the historical data. So after we put that current data into the model, we can get predictions about what will happen in the future, right? So we use historical data and build the model. Then we put the current data into that model and do predictions. So that is what happens in data mining. Okay. So next we will talk about supervised and unsupervised learning. So supervised learning means the training data includes both the input and the results. So for example, classification is a supervised learning method. So in classification, as I mentioned previously, we know what are the categories that we are going to classify the data into. So the results, the desired results, we know what will be the result, like what the result will be either one of these categories. We know about it. For example, let's say after analyzing a certain data, a certain set of data, we know whether to sell that land or not. So let's say you have a land with you and you need some money, but according to the situation in the country and various different other personal reasons, you are in a state where you can't make a decision whether to sell that land or not, right? So then you are analyzing the data that you have. You are analyzing the situation in the country. You are analyzing the situations of other countries which were in the similar situation. You are asking opinions from maybe your parents or anybody else. You are analyzing your personal matters. So you are making a huge analysis based on the things that you have. So, however, you know what will be the categories of the result. The result will be either you sell the land or either you don't sell the land. Only these two options are there, no? So, supervised learning. In supervised learning, you know what will be the outcome. Either of the outcome you know. So, the outcome in that previous example I mentioned, the result will be either you sell the land or you don't sell the land, right? So in supervised learning, both the input and the desired results are known, okay? And for some examples, the correct results are known and given in input to the model during the learning process. So during the learning process itself, the results or the targets are given into the input model. Right? But in unsupervised learning, we do not know what the outcome will be. In situations where we don't know the outcome variable to predict or classify, we use unsupervised learning. So we can use to cluster data, as I mentioned previously. Based on the characteristics of the data can be divided into classes. So these classes we do not know before dividing these data. We do not know how many classes will be there and things like that, right? So in supervised learning, we know the outcome. The outcome will be in either of these categories. But in unsupervised learning, we don't know the outcome. How many categories will be there, how many objects will be there in one category, we don't know any of those information in unsupervised learning. So clustering is an unsupervised learning method. Classification is a supervised learning method. Okay, so I have a small activity for you to do. So there is a topic here: impact of information systems to change the management of organizations. I need you to talk about how information systems can change the management of an organization. Okay, impact of information systems to change management of an organization. So I'll give you a little bit of time because you have to do this by yourself. I'll give you a little bit of time, and like around 15 minutes, right? So you have to refer the internet maybe, or you can include your ideas yourselves, and you have to talk, you have to just note down certain points, and after the 15 minutes you have to talk about it. You have to talk about how information systems can change the management of an organization. So when you take the meanings of these words, you can you have to explain by management what did you mean, right? By an organization, what kind of organizations you are meaning, what categories of organizations, things like that. You have to support your answer, right? Okay, can you do it right now? I'll give you 15 minutes. So around 10:35 we'll start our discussion, right? I don't need a very lengthy explanation, but I need your idea. So you can express your idea in either English or Sinhala, that is okay. You have to talk about it, right? The impact of information systems to change management of an organization. Do you have any questions regarding the topic, or did you understand it? Anybody who does not understand the topic? Okay, so finally in your assignment also you have to do a presentation. So that topic will be more lengthy than this one. There will be no not only one sentence in that information that is given to you. So you have to do a presentation and in your assignment also. So that's why I'm asking, you have to talk about this topic, right? So I'll give you yeah, at 10:35 let's start discussing. Okay. Yeah, so did anyone of you complete with this activity? Can we discuss about it? Or do you need more time? Yes, anybody completed this? So I just need your opinions. So we have to discuss about this topic here. So how information systems can change management of the organization. So can I have Anjali? Can I get your ideas? Anjali, are you there? Yes, Anjali? You can start. Okay, are there any volunteers? Can somebody explain his ideas?
Yes, ma'am.
Okay.
It can reduce the number of levels in an organization by providing managers with information to supervise larger number of workers, and by giving lower level employees more decision making authority. And it can help to and uh, it can help to minimize labor cost and support to make a better decisions in organization.
Yeah, can you give an example for the ideas that you are mentioning? Maybe one or two examples. So how can an organization's lower level employees uh, make decisions based on the information systems or some anything like that? Yes. Okay, Vinisha. Vinisha, right? Can you hear me? Yes, Vinisha, can you explain? Can you give your thoughts? Sarangi. Okay, I need you to talk because I mentioned that you have to discuss about this. So, any one of you, I mean, all of you have to give your thoughts. You have to explain whatever your ideas about this impact of information systems to change management of organization. Yeah, Anjali. Yeah, I'm not going to ask you again, so I will be waiting until all of you explain something. So if you want to continue the lecture, you have to talk.
Transaction cost theory.
Sorry.
Transaction cost theory.
Sorry, I didn't get it. Can you mention it again, Sarangi?
Transaction cost theory.
Yeah, can you explain it? Can you explain what you have mentioned? I didn't hear it properly either. I don't know whether the other people have heard it. How about the others?
You can use transaction cost theory to reduce the cost in organization. Yes.
Yeah. Okay. So, yeah, go on.
Yes, it's traditionally grow in the size of reduce the transaction cost. It potentially reduce the cost of for a given size. Shifting and transaction cost of grow inward, opening up the possibility of revenue growth without increase in size, or even revenue growth accompanied by shrinking size.
Yeah, you can use, actually you can use different kinds of theories or methods which are there which are available with information system, maybe packages like that. So not only transaction cost theory, so there can be many kinds of theories associated with dealing with the management of the organization. So information systems, when it comes to information systems, there can be certain applications or certain packages available. I think if you have an idea, if you don't have an idea, you can go to the internet and search. And I think on the last week also I have shown you some videos regarding certain packages where certain management theories are applied into these software packages, and these software packages or these systems can be used in large organizations for the betterment of the organization. So basically for the management level of the organization, these information system packages can be introduced. So all the management theories and all the business related theories and strategies are included in these systems, information systems, and we can use, or the company or the organization can use it, and as some of you have mentioned, they can reduce the labor cost, and most of the things can be automated inside an organization. Almost everything is automated nowadays. Since there are less people involved when information systems are there, the human involvement is reduced. So the number of errors or mistakes which can be done by the human, and the time cost and other physical costs can be reduced with the use of information systems in an organization. Okay, So like that. So in a business, we can use certain information systems packages, or yeah, we can say, we can name as packages in order to do their day-to-day activities and decision making, and um, to achieve their business goals. Okay. Okay, so that will be about the general business analytics part that we are going to business analytics and intelligence part that we are going to cover. Okay, so I will send these lecture notes to your course coordinator, and he will send it to you. Okay, so I mentioned that you have to, so we are focusing in this lecture series here, we are focusing on basically information systems based on geographic. So geographical information systems, we are focusing on it. Okay, so before that, let me know if you need more explanation on any part that we did previously. Do you have any questions regarding the data analysis and stuff?
It's clear, ma'am.
Okay. Okay, so we will be talking about geographic information systems from now on. So you are having your assignment based on some analytics parts of geographic information systems. So GIS, basically we call it GIS, Geographic Information System. So we will be talking about what geography is and what is an information system. So what is geography? So when we talk about geography, it is anything related to the earth, right? Anything. So not only the environmental or natural things, even man-made things also can be talked with geography. So for example, all the mountains and rivers and plains and beaches and countries, so all of those things, yes, we can talk about them in geography. And also all the schools and churches and temples and even the population of a country, the political ideas of the people in the whole country. So like that, all every information which is spread across the earth, right? Every information which is spread across the earth, we can talk about it in geography. right? So when you say geography, don't only think about the natural things on the forests and mountains and rivers. Yes, not only those things, but the population of a country, the religious distribution in a country, the political views and distribution in a country, right? The man-made monuments, how the schools are distributed in the country, how the churches and temples are distributed in the country, the restaurants and cafes and hotels. So everything which is distributed on top of the earth, and every concept or every distribution, we can talk about it when we talk about geography. And information systems, I think you already know what an information system is, so you have talked about it again and again, maybe not in this subject, maybe in other subjects as well. So in information systems, what happens is we have a certain system, software or application where it gives a particular result based on information gathered from various places, right? An application or system which gives a particular result with all the information and data gathered from various places. Okay, so geography is basically the study of the earth, the study of lands, features, inhabitants, and phenomena of the earth. So even the phenomena means anything which is happening, maybe the climatical changes or political changes, all the things that is happening on top of the earth, we study through geography. So information systems, basically what happens is we collect data and information, we organize data and information, and we store data and information, and finally we communicate them with each other. Okay, the collection, organization, storage, and communication of information. Collection, organization, storage, and communication of information. So geographical information system means there is geography and information systems, both of them are included. So GIS comes in this middle part. Okay, GIS comes in this middle part. So there is geography and information systems. So in a more technical manner, GIS means computer systems and programs that help answer questions about the world. So based on the things which are stored, maybe maps, maybe other kind of data, which can be stored in a database or any other medium. So when we put all this data and information into a computer system or into a program, so that program will help you to answer certain questions about the world. So what are the questions about the world? So normally, what are the questions that we talk about the world is where a certain thing is, where is it? So I think all of you have familiarized with the Google map, right? All of you know what happens, and I think you have used Google Maps. So what happens there is you search for something and the map will give you the result where that particular thing is. For example, you search for a town and the map will show you the location of the town. You search for a restaurant, the map will show you the location of the restaurant. So where a certain thing is, you can find it through the Google map. So the Google map is actually one of the best applications which is related to geographic information systems, right? So where is it is one question that you ask about the world. What else is nearby? So that is another kind of question you are asking about the world. So what else is nearby means, for example, you search for a certain maybe hotel, and then you search what are the restaurants nearby that hotel, right? You search for a hotel, and then you search what are the restaurants which are nearby that hotel. So like that, what else is nearby, and what are the shopping complexes, or what are the activities that you can do nearby your hotel. So normally a foreigner or a tourist, when he goes to a place where he hasn't been previously, he can search for, he will have these kind of questions in his mind. Where is it? What else is nearby? Like that. So he can get answers using the world's most famous GIS engine called Google Map, right? And another question is, where can I find things with certain characteristics, right? Where can I find things with certain characteristics? For example, where can I find places to stay which has the value less than some amount, right? Less than 10,000 rupees. Where can I find places to stay less than 10,000 rupees, something like that. Okay, so there are certain characteristics for them. And where is the closest certain place to my location? So what is the closest restaurant to my location? What is the closest train station to my location? Like that you can search. And not only Google Maps, there are certain specific applications where you can find these kind of information. For example, your taxi driving app. So you know there are PickMe, Uber, and many kinds of taxi applications. So you can use these applications also to find the closest cab service, things like that. Or you can use applications like Uber Eats, PickMe Eats, and find the closest shop. Or most of the shops nowadays, they have their location on the Google Map. So shops with many branches like Pizza Hut or KFC or McDonald's, so those kind of shops, they have many branches throughout the country. So you can find the closest, maybe the closest KFC to your location, the closest Pizza Hut to your location, like that, right? You can use the Google Map itself, or otherwise you can use the specific applications to find the location. So like that, you can have many questions about the world. So these kind of questions can be answered using Geographic Information Systems applications, right? GIS applications. These kind of questions can be answered using GIS applications. So GIS try to model things on the earth. So there are things which are existing on the earth on real time, and we can model these existing things on a small map. So usually the map which can fit into our mobile screen. So imagine even a part of a map, when fitting it into our mobile screen, it can be, everything on the earth are fitted into our palm top on our mobile screen, right? So everything on the earth is modeled into an application, so that is also called, we can call it as geographic information systems. So there is a process to build these models. There is a certain process to build these models. Okay, so first of all, we cannot say anything like first of all, but this is a circular process. So let's say let's start from here. We are collecting data and information using the different kinds of ways like remote sensing or satellite data, or we can record real-time data, maps and stuff. We collect data and then we convert that data into information and we store the information. We take the information from here and analyze it. So we can use any analysis techniques that we talked about in the previous slides. Then after analyzing, we visualize the data. So here we can visually see the data, and then we make decisions, or we make plans, we build plans. Then we make decisions based on the plans. We make decisions and we can build a map based on the decision or based on the data that we have visualized here. And these maps can be again used in data collection with the help of other data collection methods. And this process goes on and on because these data can be differed from time to time, maybe due to climatical changes, maybe due to political changes, maybe due to any other changes in a country or on the earth. These data can be differed, right? It can change. So time by time we have to do this process again and again, because new data will come and some of the old data will not be existing, or they will not be valid. So the objective of this GIS is to improve overall decision making. The objective of GIS is to improve overall decision making, right? So finally we have to make the best decision with the use of the current and past data that we have. So we can use different kinds of software applications to work with GIS or Geographic Information System. So GraphGIS is one software, ArcGIS, TerraGIS and QGIS. So there can be many other software applications also. So we will be dealing with QGIS in our course content. We will use QGIS because it is free. It is a free application. You can download QGIS from the internet and install it in your computer, right? Or otherwise you can ask your institute to provide you with an executable file. But however, it is freely available on the internet and it is not much hard. You can download and install it. ArcGIS is also available, but it is not free, or at least some of its parts are not free. You can like use a trial version or a limited application with limited services you can use if you are using ArcGIS. So I will be doing all of your practicals and stuff using QGIS. Okay, so you can download QGIS from the internet and install it. Any version that is okay, but make sure you install somewhat a new version, because in the older versions, some services or some some services will not be working in the old versions. So try to install the newest version when you are installing QGIS. So we will be doing practicals with the QGIS most probably from the next week onwards. So make sure you install QGIS and be ready. So when I am doing the practical here, you will be able to do it by yourselves, right? So we can all of us can do the practicals together, and then afterwards you can do some practice questions, right? So try to install QGIS before coming to the lecture on the next week. So we'll talk about what can we do with GIS. Basically, with GIS we can make maps. What we are doing is we are making maps with GIS, Geographic Information Systems. We can make maps and charts also, right? So here are some examples of example maps that we can build. So transportation maps, state atlas maps, so all the natural phenomena is included in this map. Aeronautical charts where the planes and other navigations are being done, right? And we can also put information on top of the maps, right? So we can read the maps, but not only reading, we can also include some things in the map. So you can include your business in the map, right? You can include your business, or you can include your institute on the map. You can include them. You can give information about existing locations, right? Whether the information are true or not. You can state them. You can add more information, right? So important information you can put on the map. So any map has this concept of layers, right? All of the maps have the concept of layers. So layers means different kinds of levels are divided when drawing the map. So for example, when we take a map, we can have one layer for the land usage, one layer for the streets. All the streets are drawn in this street layer. All the districts are mentioned in this districts layer. All the parcels that is related to the map, it will be mentioned on this layer. So like that, there are certain layers for each and every categories on the earth, right? So things in the real world is modeled on top of a map. So yeah, you can see this another example where this is the main map, a map of United States. So there are many things drawn on top of this map. but we can divide this map into layers. So one includes the rivers, all the rivers in the US is included in this layer, and the other layer includes lakes. All the lakes are there. Right? There's another map, another layer which includes states, then roads and cities. Like that, information is organized into layers. So that is the concept of the map, the digital map, actually, because in the previous times maps were drawn on a paper, right, on a paper sheet. So we cannot divide the maps into different layers when the map is drawn on a paper sheet. But here, this is the digital format of a map, so we can organize the data or information on top of a map into layers like this. Right? So this is another example. The whole world is modeled. One layer will include imagery information, the other layer include elevation information, then transportation information. I mean, all the roads and signs will be shown in this layer. The addresses of the maybe individual people and organizations like that will be included in this layer. Boundaries such as provinces, districts will be included in this layer. Water features like holes, wells, lakes, tanks like that, or rivers, all of the water features will be included in this layer. Then other data like survey control will be included in this layer, and the data that we are inputting, if we are recording some data on top of a map, then our data is also there. So all the whole map is created using different kinds of layers. So inside one layer, all the things inside that layer will be related to each other. For example, when we take this transportation layer, all the roads, the railway lines, and other transportation related like bus stops, bus stands, train stations, those kind of transportation related information will be stored in this layer, right? So that is how a digital map is being created in a GIS application. There are layers. Okay, so GIS can also answer questions. So what kind of questions can GIS answer? It can be anything like this. What is the closest Pizza Hut? Where was the last earthquake happened? The population of people in the United States, how much? What was the land cover of Vilpattu Forest in 1990, and what is its current value? So every question like this can get answers using GIS, right? So that's what I mentioned. GIS does not only mean about the trees and rivers and lakes in a country. Okay, so the land cover, how much land is there, so those kind of information also can be there as a question related to the earth. Okay, so if I ask you this question, how do I get to school? Explain the route from one point to another. So I'm going to ask this question from one of you guys. So how do you get to school? Can Anjali explain? how do you go to school? Like when you were going to school, how did you go to school? How did you go to school means the route, right? Explain the route from your house to the school. Yes, Anjali, can you explain? Yeah. Yeah, go on. Yes. Let's say some foreigner is coming and he is asking for a place to go. He is asking about a place, right, where he can go. So, how are you going to mention the route to that person? Yes. Yes, somebody. Just just mention how you are going to, like how you are going to tell the path to go from one location to another. What kind of things you are going to talk when you are mentioning the path for a person? Path or route. Yes. Okay, so you can think about this by yourselves, right? So how, when a person asks you how to get to your school, so how you are going to explain the route from one point to another, you can think about it by yourselves. Okay. So yeah, how GIS can be used in the real world? There can be many fields where GIS can be used. So GIS is already being used in energy forecasting activities, agricultural efficiency, carbon management, aviation safety, and many other fields. Because all of these things, all of these information is related to the earth. Maybe not directly to the natural nature of the earth, but everything here is related to our world, right? So GIS can also help us to plan certain things. GIS can help us to plan certain things. So GIS is nowadays it is being used in city and urban planning, method. So you can build whole cities, you can plan whole cities. Unfortunately, you cannot see these kind of things in Sri Lanka. In some parts, actually, certain cities have been built, but it is very rare in Sri Lanka. But I don't know whether you have that experience, but when I was in my first years in Matara was a very complicated town. It was, I mean, small shops were here and there, and it was like a very not an organized town. That was around 2009 or 2010, like. Then afterwards, the roads were built, and there were certain. I mean, the town was made into a certain. It was built according to a certain plan, right? The town was rebuilt according to a certain plan, right? So and you can, and the current situation or the current view of the town has been generated using that plan. So not like that actually. Here we mean about whole cities and countries built from zero level itself, right? So the whole place or the whole city is being developed from zero upwards. So it GIS can be used in that kind of city building and planning, right? So this example is of California, and virtual cities can be developed. So Bangkok has these kind of virtual cities. So mostly what happens is before the country or before the government build the whole city, they create a virtual city. The city is not there existing in the real world, but a digital copy or digital way of the city can be used, and certain decisions can be made by using this virtual city, right? Using the land in a suitable way can also be done using with the help of GIS. So in this place called Montana, the land, since there are so many deserts around it, the land was suitably used into growing certain products. And even in places like Dubai, even though there are deserts and lack of water around, their land, they have used their land in a very suitable manner, where they are able to grow certain crops, right? So they are challenging the deserts and everything. And GIS can also be used to manage the land. So building the maps and building maps with the information which is stored, right? So integration land management. So land management can be done. So in land management, what happens is the size of the land and all the details of that particular land will be stored, right? They will be recorded, and whenever that maybe that land is being used by something, maybe a government body or maybe a private owner, when the details are changed, that integrated land management, the storage or the values will be changed. So tax mapping, people who are paying taxes, people and maybe institutes who are paying taxes, they will be shown in this map. Property evaluation can also be done by land management, right? So what are the properties which are available, what are the costs of these properties, those kind of things can be managed using GIS. We can increase public safety and help law enforcement. So public safety means both natural and man-made safety precautions we can take. So one is this kind of things can happen or spread naturally. So fire response, how the fire is being spread, those kind of information can be put on a map. And when visualizing the map, you can see there in the borders, the population have to flee away in this kind of situation. Let's say there's a fire, right? And crime analysis, what are the criminal activities being done in a certain town or village, and maybe who are involved, what are the number of criminal activities happen, those kind of things can be mapped, and crime analysis can be done, right? So in order to eliminate these criminals, they do crime analysis. Okay, so these are some other examples of managing how management of natural disasters are being done using QGIS or GIS. So you can go through these images and see. Yeah. You can manage electricity, water and phone. So how these cables, how these networks are being created, you can use GIS in order to get the help to build up these kind of networks and highways like that. So transportation, how to model transportation. I think you have this experience with Pick.me, Uber, and various kind of transportation. GIS can be used in earth science and water resources also. So how certain climatical and natural changes happen, we can monitor using data put in GIS applications. We can predict floods. We can use information like online soil information, which is based in Australia, and we can use them in other countries as well. So this kind of earth science and water resources can be helped using GIS. And we can monitor climate and energy. So what are the climatical changes which are happening? How much energy is remaining in the world? Maybe in a country, how much energy? And what is the climatical status? Those kind of things we can monitor. Yeah, so this is another example of impact of global climate change. So you can see how things have been deferred from some time and some places, how climate is changed. Yeah, we can use GIS and its data to protect the country, right? So we can build models about any information protection related information in a country. We can build models or maps or model areas with the aid of GIS data. Security, how to provide security for the country or some areas with related to the data, GIS data. We can use global surveillance, right? Global surveillance to protect the country. So all of these things we can do based on the data and the how this data is being used in a GIS application and how this data is being mapped. So when we map the data and when we visualize it, we are able to make decisions about the protection of the country. Okay. Okay, so you too can use GIS in the real world. So what you can do is you can find and collect information, field information. You can add information on certain GIS applications like Google Maps. you can add the information that you find. So it will be used for the betterment of the people who are using the Google Maps. For example, you go to a certain village, maybe a rural village, and you go to a certain small shop or small boutique. So you have maybe something to eat within that shop, and you buy certain things, and you are very much satisfied. So when you go to the Google Map and search for that shop, that it will not be there. It is not available. So what you can do is you can include that shop in the Google Map, and you can add a review for mentioning that you have had a very good experience here, things like that. Then other people will see it, and they will come, and they will also add some reviews. So like that. So that is how you can contribute to GIS, right? You can find information, and then you can store that information or upload that information into a GIS application platform. So basically the Google Map is the best and the most famous application. Okay, so before further talking about GIS and other stuff, we will talk about something called GPS. I think you already know about this. You already know about GPS. GPS means Global Positioning System. So based on this GPS value, actually, the GIS application called Google Map is working, right? So among the earth, or on top of the earth, where you are on top of the earth, the precise location, we can get it using the GPS or the Global Positioning System. Okay, so the Global Positioning System, this is how it works. 3 or more satellites have been orbited around the earth. So the signals and the signals from certain devices can be absorbed to these satellites, and using that they are able to provide the most accurate positioning system, right? So when you open the Google Map, it will indicate where you are on the world, on the earth. It can indicate where you are on the earth, right? So GPS satellites can be used, and they can take data from certain places, and cellular network or satellite communication can be used to store that data obtained in a gateway, obtained in a server, and this data will go through a gateway and come to your mobile phone and computer and many other places where a map can be used. Okay, so who use GPS? Can anybody of you just think and tell who normally use GPS? Yes, who normally use GPS? Yes, come on, speak up. Anybody can you tell me who use GPS?
Hello.
Yeah,
Pilots, boat,
pilots.
boat captains,
Yeah.
uh, agriculture workers,
Mm-hmm.
um, scientists,
Mm-hmm. How about the general public, like you and I?
Taxi.
Yes, we also use GPS, right? If we are using the Google Map to go from one location to another, we are using GPS to see where we are at the moment, right? So yeah, good. So GPS can be used by many people, many in many fields also. So pilots can use GPS in order to fly from one location to another. Similar goes to people who are navigating in ships, and people who are there in a war, right? Soldiers and people who are involved in agriculture also, they can use GPS. So almost everybody use GPS in their day-to-day activities. Okay. Okay, so how to answer GIS related questions? How to answer GIS related questions? So this steps you can use to answer any question which is related to GIS. So for example, you can think about a topic or a place. For example, you want to go to a certain place. Then you must ask a question about it. Where is that place located? What is the size of that place? What is nearby? The elevation, anything you can ask questions. You might have a lot of questions about a certain place, and then you can include all of them in a map, right? You can include all this information in a map. You can perform any analysis. You can ask a new question about that place, and like that you are ongoingly you can ask questions and you can analyze, right? You ask questions and then you analyze based on the data that you have. So that is how you are going to answer any GIS related questions. So for example, that is what is happening in most of the climate, meteorological departments, right? Meteorological departments. Okay, so the people who are dealing with the climatical changes and all that stuff, the people who are talking about the rainfalls and will it rain today or will it rain tomorrow, the weather forecast and those kind of things. So what they are doing is they are using historical data, and they are using current data also, and they are asking questions. Asking question means they will query whether that it will rain tomorrow, or what will be the rainfall, what will be the temperature, or what will be the humidity tomorrow, right? And based on the data, the current data that they have, they are going to make a map, and then they are going to analyze that map, and they can ask a new question, right? They can provide answers to those questions, and then it will go on and on, day by day, like that. Okay, so GIS related questions is normally an ongoing set of questions, because things on the earth usually change from time to time, right? So you also can think about a place and ask a question. So these are kind of questions you can ask related to GIS. So these are not very complicated questions. You can see here, they are not related to climatical changes or anything like that, but it is related to our day-to-day lives. So these simple questions also can have a relationship with GIS, right? So you can go through these questions and see they are very simple questions. Okay, so these are some examples where we can use GIS for everyday in our everyday lives. So in this image you can see so you can use GIS for mapping, decision making and planning the future. So that is the basic thing. So this is why I am saying again and again, this is the basic and the main thing that you can use GIS for. You can map, you can make a decision and you can plan the future based on that decision. Plan a better future, right? Yeah. So GIS can be used in engineering design, demographic analysis, topographic analysis, right? So facility management, logistics, network analysis. So you can just search about these things if you have an interest about it. I'm not going to explain these one by one. These are some examples that you can where you can use GIS. Okay, so yeah, so this is about QGIS. I will explain about QGIS when we start doing our practicals actually. And okay, only 2 people are there, right? So I will just so just basically explaining why GIS is unique. So GIS handles spatial information. So what is spatial information? Spatial information is information which we can reference by its location in space, right? So we can refer the information by its location. For example, when we talk about a certain maybe a shop, we ask, we normally, I mean, if you want to send a place of a shop to your friend, what you can do is you can share the location. So by sharing the location, what you are doing is you are sharing the spatial information, maybe the latitude and longitude value of that particular shop. You are sharing it with your friend. So the application called Google Map, it gives you a link where you can share. So your friend can click on that link and go to that space or go to that particular location. So that link is the spatial information which is shared. So spatial information is an information where we can talk about it with the reference of a location. We can talk about its location, right? So almost everything on the earth can be referred to spatial information, because we can talk about everything on the earth by using its location. We can either mention the latitude and longitude value, we can mention an address, we can mention anything near that location, right? Anything related to that location, like that, right? So remember, in GIS we are using spatial information. GIS makes connection between activities based on spatial proximity. So when we talk about any activity or any phenomena, for example, a rainfall in some situation. Or if we take one of the most recent example, the protests that is going around the country, right? We say there is a protest in Nugegoda, we say there is a protest in Matara, there is another protest in I don't know, Anuradhapura. So Nugegoda, Matara and Anuradhapura, those are locations, right? So we can make connections. So there we are talking about activities which are happening in certain locations, right? We say Matara, we say Anuradhapura, we say Colombo. So those are locations, maybe not latitude and longitude values, but the names of the cities where they are located. So like that, any activities also we can mention using the spatial information, right? So this is one example where GIS have been used in 1854. It is a very old incident. In London, the disease called cholera was spread in a very large amount and in very many places. This disease called cholera was spread in 1854. So people like scientists and the authorities were unable to identify why is this disease is spreading so much. So they searched for everything, and then what they came up is they came up with a map with water pumps. The map indicated water pumps and the cholera deaths which happened in that particular city or country. So they identified that most of the cholera deaths were happened near the water pumps or within certain distance from water pumps. So they then the authorities decided and they understood that this cholera was spread due to water. They spread this disease was spreading with water. So they took the necessary precautions in order to stop spreading this disease. So that kind of decision was made. It could be made because of making a map or visualizing the spatial data like this, right? So GIS has developed from digital cartography and from database management systems. So digital cartography means digital cartography and computer aided design. CAD means computer aided design. Computer aided design. So we are designing something using computer. We are designing something with the aid of the computer. So digital cartography is being used in GIS, and database management systems are also being used in GIS. So so here we are not using MySQL for using spatial data to locating spatial data. We are not using the general MySQL database, so we will be doing about that database systems also. So we are using some special database system called PostgreSQL, where location data can be also included in the database, right? So we will be doing it in the future lectures. So yeah. So the GIS process, this is the basic GIS process. So we capture data, we register the map base, we interpret data, we understand what is meant by that data, and we convert data to digital format. We can convert the data that we have captured into a digital format. We can store that data in a computer or in a server, since it is a digital format of data. We can process the data and then we can display the results. So this is the general process which happens using GIS, right? This is the general process which happens with the use of GIS. So yeah. So these things I have included in your slides. Actually, you can go and read for them by yourselves. So spatial database and attribute database can be found in the GIS system, and there are many systems which are involved with the GIS system, where certain data are being extracted from external resources, and certain data are sent to external resources as well. Right? So this is about that concept of layers that I have mentioned before. Right. So GIS is the very popular concept of GIS is this data layer stacking. So you for each and every characteristic or spatial detail, they will be stacked on top of stacked as data layers on top of each other. So GIS can be used in many areas like geosciences, civil engineering, transportation. So you can check for these right. So these are some software that you can use with GIS. GIS, ArcInfo, ArcGIS, MapInfo, GRASS. So you can search for these software. AutoCAD is also a GIS related software because it also uses spatial data. So like that you can search, you can try these applications if you like, and image processing applications are also there. So if you they can also be used in digital image geographical information systems. Yeah, the major services which can be given with the geographic information system is GIS application software development. You can develop applications regarding GIS. You can develop remote sensing projects. You can do thematic mapping, digital image processing services, engineering application, software solutions, data conversions, complete GIS implementation, consultation. So these are actually some fields that you can work with using GIS. So I don't know about, I mean, I haven't seen most of these things happening in Sri Lanka, but in other countries, these kinds of fields are there. So you can work in any you can provide this kind of services with the help of GIS. Okay. So yeah, when we talk about components of GIS, you should have a computer system, both hardware and software. So So hardware are the basic components of the computer. I mean, the personal computer, it is okay. We can use a personal computer to work with the GIS application. It is not much complicated or large application. So for software, actually ArcGIS, QGIS, those kind of applications we can use in order to perform GIS operations. So here this is also how GIS application is working. So you can roughly go through this images. It is, I mean, you do not need to thoroughly understand and by heart these diagrams. So for GIS to work, we should have both hardware and software, and we should have data, geographical data actually. It can be a hard copy map or a digital map or photos or satellite images or anything that can be used for GIS operations, right? And we should have certain procedures and analysis. So we have to analyze the data. So we have to have certain processes in order to analyze the data. So we can include both hardware and software here in order to analyze the data, geographical data. There should be expert and skilled personnel, because in order to handle these geographical data, you have to have a knowledge or skill related to this geographical data, right? Experts with knowledge area are required to apply GIS properly. Different types of users are using GIS at different levels. So there should be an expert, and I mean, there should be a person who knows GIS and who knows the technical part of GIS in order to work with these applications. So GIS, main functions of GIS are data capturing. So we can do digitizing, scanning, importing, manual data entry. We talked about how we collect data, right? So based on those methods, we can do data capturing. Then data storage and management. So the captured data should be stored and it should be managed. So databases, data integration can be done in order to store and manage data. Data manipulation and editing. So we can clean and edit data, georeferencing, layering, those kind of things we can do, and we will be talking about those things in future lecture series. Then afterwards we can display data. So displaying spatial data is done on top of or by making maps, right? Data manipulation and analysis can be done using spatial analysis. So for spatial analysis, we can do simple searches, network analysis, buffering, corridor analysis, proximity analysis, those kind of things. So you can search for these methods and get an idea about these methods, right? This is actually for your references. And I have also listed some other applications of GIS where GIS can be used in geography, geology, meteorology, those kind of disciplines. And yeah, in agriculture, how GIS can be used in farm management, pest and disease tracking, crop monitoring, those kind of things. So in foreign countries, actually, they are using GIS for these kind of activities. And GIS can also be used in natural resource management in these fields, how we can manage our resources. Okay. and planning and economic development, as I have mentioned before, town and country planning, how we can forecast the population, market analysis, tax analysis, transportation, those things can be done using GIS. So yeah. So what are the challenges for the geographic approach? The climate is changing day by day. Urbans are growing. Agriculture should be sustainable. Then water quality, energy, national security. So those kind of things are changing day by day. So all of them are challenges which require a geographical approach, right? So geography or GIS is used in so many departments. Software, instruction and data should be coordinated with each other. Software, instruction and data should be coordinated with each other. So as I mentioned on the first day, data is very expensive. I mean, data is there everywhere. So if we use data in a very suitable manner, we are able to gain very accurate information, and we are able to make very accurate predictions for the future. Okay. So you can go through these lecture notes. I'm not going to explain this one by one, because these are just for you to read. Okay. Yeah. So next we have to talk about the data structure that we are using inside GIS. So we'll start from we will talk about this on the next week. Data structures, and there are map elements that you need to know before you make a map. There are certain map elements that you need to know. So we will talk about these things on the next week. So I will send these lecture notes to your course coordinator, so he will probably email to you guys. Okay. So any questions that you need to know, any questions that you need to clarify before we conclude in the lecture today? Anything that you need to explain again? Maybe not maybe today, maybe on the next day also.
No, ma'am.
Okay, so everything is clear. Okay. Okay then, so we will continue the lecture on the next week, and remember, when you are coming on the next week, please install QGIS in your machine and come. So we will start our practicals from next week onwards. Okay. Okay then, until then, have a nice week.
Okay, thank you, ma'am.